Today I'm with a video to say about mesomeric effect. Let us know about the definition of mesomeric effect. Here, our mesomeric effect tells that polarity produced in a molecules by interaction of two pi bonds or between a pi bond and a pair of electrons present in an adjacent atom. Now, let us know what is meant by polarity. Polarity in the sense, now we'll take an example of H2O. We say H2O is a polar molecule. It is a polar molecule. Why it is a polar molecule? Because H has slightly positive charge, delta positive, and O has slight negative charge. So it is delta minus. Polarity in the sense, it is like negative and positive charged combined in a ratio to produce a molecule that is known as polarity. So polarity produced in a molecules by interaction of two pi bonds. Same pi bonds, if interaction is there, then mesomeric effect takes place, and a pi bond and a lone pair effect is there, then also you will get a mesomeric effect. This is the definition, basic definition of mesomeric effect. Now let us take an example of mesomeric effect. So first we will learn about, there are two types of mesomeric effects. First is plus M effect, that is plus mesomeric effect, and we have minus M effect, that is minus mesomeric effect. So now let us see about plus M effect, that is plus mesomeric effect. So let us take an example of phenol. We are taking an example of phenol. You guys know what is phenol, right? A benzene ring having OH group is known as phenol. Here O has lone pair on it. When this lone pair electrons shift towards the pi bond, this pi bond donates electrons towards the benzene ring. So here electron donation is taking place. Donation is taking place. So whenever we have whenever we have resonance of donating electrons, then we have plus M effect possible. So this is one of the example. Whenever you just remember, this is a tip for you, whenever we have a lone pair and a pi bond, then the resonance happens by donating the electrons to benzene. When the electrons are donated towards the benzene, then plus M effect takes place. This is a simple and easy trick to remember. Wherever there is a lone pair and a pi bond, then the shift towards the benzene ring takes place and we will get plus M effect. One more example is NH2. You can see here. What is this? Benzene ring attached to NH2. So the compound name is aniline. So here also we have plus M effect because the resonance is donating the electrons towards the benzene and we have a lone pair on N. So it is plus M effect. Hope you all understood. Now we are going to know about minus M effect, that is minus mesomeric effect. Let us take an example of benzaldehyde. Benzaldehyde is a compound nothing but having benzene ring having a aldehyde is known as benzaldehyde. Here O or resonance takes place such that the pi electrons shift towards the benzene and the benzene shifts its electron towards the more electronegative atom in that compound. So this is electron withdrawing group. So it is ready to take electrons, so it is ready to gain electrons. Only when the compound is ready to gain electrons, then minus M effect is shown. Another example we can take is NO2. Like for a benzene, there is NO2 attached, so resonance takes place and again the same process continues and it will show minus M effect. We are going to see some more examples. Here in first example, for the benzene ring, we have CH3, that is methane group attached. Here, if we try to answer this question whether it shows plus M or minus M effect, it shows no effect. According to our definition of mesomeric effect, when we give a look here, polarity produced in a molecule by interaction of two pi bonds or between a pi bond and a lone pair, only then mesomeric effect takes place. Here we don't have either lone pair, either resonance. There is no resonance at all, so there is no chance of having mesomeric effect, so it shows no effect. Next we have OCH3. We have lone pair on O, so such that it shifts electrons and benzene ring moves. The further process takes place. As we have a lone pair here, it shows plus M effect. And here we have pi bond and pi bond. Again, between the pi and pi bond, if it takes place, I said you that it is minus M effect. So that was today's class. Hope you understood the plus M effect, minus M effect and the no effect. And this was the mesomeric effect concept.